Hey everyone, I hope you all are safe and doing good. So now you know about linked list. We have discussed in the previous lecture what is a linked list. Let's see now in this lecture what operations we can perform on linked list. Because on arrays also we can perform many operations like insertion, deletion, searching, traversal and many things. So same, it's a list, same we can perform many operations on linked list as well. The very basic is traversal itself. Suppose there is a list, you have to print that list. So you have to visit the node of the list at least once, all the nodes. So that is nothing but traversal of the linked list. Insertion. We can insert some node, new node in the linked list. Yes, we can do. We can delete a node in a linked list. Yes, we can do. We can search, right? So this thing. In this lecture we'll see basically how to traverse and how to insert, because insert also are having many cases. Insert at the beginning, insert at the end, insert at any position, or insert after a given value, or insert after a position. Many cases can be there, so we'll see one by one all these cases. Okay, now you know how to create that node and all. So let me just first see how to traverse the linked list, because this is the basic one, traversal. The basic, how to print a linked list is, at least we should know how to print a, if you have a linked list. So this is the basic one. Let's see how to traverse a linked list first. So we are discussing first now the singly linked list. Singly linked list means we can traverse in one direction itself. Every node is having, this is a node, the node is having two parts: data part, which is containing the actual data; second part is the reference to the next node, only reference to the next node, so we can move forward. No node contains address of the previous node, so that's why it's a singly linked list. We can go in one direction only. 1D kind of linked list is this. How to traverse it? Suppose I have a linked list. I have assumed that I have this list. Somewhere, somewhat I have created this list. I have inserted these things. How to insert? I'll tell you that thing also. But now suppose I have this list. Now how to traverse? How to print? How to visit the elements? All the nodes of this one by one. Last node is having null. We know. First node is like, it's a reference object, we have reference pointer, we have reference variable, we have head that is containing address of the first node. So we know only the, we have only the reference of the first node, that's it. Have to traverse each, we know that each node is having address of the next node. Yes, so what do you think, how to write this thing? We'll first move, print this, then move here, print this, then move here, print this, then move here. Once print this, and once you got null pointer, stop. Something like this we do, right? But suppose you are writing something like this. So simply if I say while head, head is not equal to null, because we have only head itself, that's it. We don't have any other reference object or pointer and all. While head not equal to null, till then we will move. Till then first system.out.println, we will print the data. How to access the data? We know that we have something like this, head dot data, because this is a reference object. So dot data we can access, dot data, something like this we can print. And suppose you want arrow also, if you want to print a list something like this in the output, 10, then we have an arrow, 15, then 3, then 4, like this. These are linked, and at the end we are having, you can say null, you can say null, or you can say end, something like this we can. So to print this arrow, we will basically write down this thing here in system.out.println, print. But now it, this line will print 10, but you have to now move head here, because now I want to access the next thing. How to move this? So you can just change this head. In head I want this address 2000, then only this head will point to here. From where you will get this 2000? From here. So head dot next. So in head dot next we are having this 2000 equal to, assign this to head. Now head becomes head not next. Head not next is 2000. In head now we are having 2000 now. So this is pointing to this. Yes. Same check now. While head is not null. Yes, head is not null. In head I am having this. Again print the data. Move this. In head now we are having 3000. Head is not null. Again print the data. Move this. Then then we can see that head not equal to null. Print the data. Again head is equal to head next. So now in head we are having null. Again check the condition. Head not equal to null. No, head is null. So stop. But okay, now see, at last we are having here my head. But now the problem in this scenario is what? Because now you have lost the reference to the starting of the list. How you will go back now from where the list is going to be started and all? So head is here, right? But that thing we cannot afford in linked list. So very first thing you have to remember is what? You cannot change, you cannot move head at any cost, because we cannot afford to lose the link from the starting node. No, we can't. So what we can do? This thing will not work. We cannot move head. Okay, it's okay. We can create our own another reference variable. It's fine. We are having our own class node, and there we have in data and all that we have seen in previous lecture, or practical also I'll show you, right? How we are going to write that thing? Basically we have to create a node. We have our own like node user defined data type. Here we are having int to field data, and next is a pointer of type node. We just name it next. Any name you can take. And here we can have that constructor. If you want to initialize at the time of creation itself, you can take constructor. Otherwise you have to take value from the user, enter data and all for the node. So I'm just assigning the data itself, int data. So how you do this thing? This dot data is equal to whatever the data. This thing, I hope you know this pointer and all, because we have seen in Java course. So this dot Java means this is going to refer this field, and this is going to refer this name of this parameter, right? And we are having this dot next pointer would be null. That's it. Whenever you create a new node, we give the data, and next would be null by default. So this is basically the structure of the node. This is how we create. So we have created this in our program, I assume that. So if you create head, so simply we can write here, before we write here in the program somewhere node head. So we have created a head reference object, reference variable, that is now right now storing, because we haven't initialized head, so null. So we can create one more node, temporary node, temporary reference variable, not node, temporary reference variable. We are not creating any node now, right now. Temporary, any name you can take, it's up to you, right? But basically a descriptive name we can take. So temporary, it's temporary. We are just taking it just to traverse the list. So take it, and at first just assign temp is equal to head. That's it. So right now we are having one more thing, temp, and this temp is also having the address 1000 and indicating or referring the first node. See, let me clear one thing. These addresses are, I'm just assuming, these are not actual addresses. In Java we don't know addresses. So these are some hexadecimal kind of value, but just to make you understand little bit in a better way, I'm just assuming address this. So that from here you get to know that okay, this address is here. That's it. If you don't want to take addresses, you can simply point something like this. No need to write address. Okay. So we are having here, just to make you understand, I'm just writing the addresses. Now head is here, temp is here. So don't move head. Same thing we do with temp. So rather than head, what we can do, I think you can say modify this. So you can pause the video and modify this. Temp not equal to null. Till then we just print here rather than head now temp dot data, and rather than head now we are doing what? Temp is equal to temp next. That's it. Yes, at first temp is 1000, not null. Means 1000 means yes, referring to any node. Yes, not null. Okay, fine. Condition true. Enter here temp dot data, print 10 with this arrow. Now next, temp is equal to temp next. Now what is temp next? In temp of next we have the address of the next node. So now temp becomes this. The address of next node means temp now pointing to this to this and just remove this link. Temp is not pointing to the first now. Now, temp not null. Yes, it's not null. Again, print temp dot data. So 15 would be printed, then arrow. Temp is equal to temp next. In temp of next, we have 3000. So now we are having here 3000. So now temp is pointing to this. Temp is not pointing to this. Temp dot data 3. 3 would be printed. After this, we are having like first 10, then 15, then 3. We are having now this arrow. Now temp is equal to temp next. 3050. Now we are having 3050. Now this is pointing to this. Note this. Not null. Yes. Temp data print 4 with this arrow. Temp is equal to temp next. In temp next, now we have null. So now we are having here null. Yes. So check the condition. It's not true. It's not true. So I'll not enter here. Now, obviously, this is kind of list, but it is still like pointing to something. So just to indicate that it's the end node, so simply you can print here at last after this loop end or null or anything, something like this. So end would be printed. That's it. So it will show that end. So this is my linked list. This is how we traverse this way. This is very important. But now there are some edge cases. If the list is empty, then what will happen? If the list is empty, if there is nothing in the list, then head would be null. So before writing this code, what we can do? We can just check one more thing here. So we can write down here if head is equal to null. Just check that. If my head variable equal to null, in that case, you can simply print list is empty, and in else part, we can do this kind of thing. That's it. Right? And we are having simple only one node. That's it. In that case also, will it work? Yes, it will work. Because it's not null. Okay, fine. We'll go to the else part. Now we create like a temp. Temp is equal to head. So temp is now this. While temp not null, yes, temp is not null. Just print the data with this arrow. So like 10 with the arrow. Temp is equal to temp next. If there is nothing here, so we will be having here null. So now temp of next would be null. So temp becomes null, right? Next, temp not null. No, this condition is not true. Exit from the loop. After this, print end, and that's it. So this is how we traverse. I hope you got this, right? Now, obviously, we need some lists just to show you practically. So first we have to create a list or we have to insert something to the list. So let's see now the second operation. Have to insert in a linked list. So first we will see how to insert at beginning. So to insert, obviously first we create a node. Have to create a node. We have this class node, so we can create easily the object of this. So we can create node is equal to new node, right? And somewhere suppose from any main method we are calling insert at beginning and we are passing the data what to insert. Suppose in main I'm calling this insert at beginning and I'm passing some data. So in the definition we have to write down one parameter to accept that data, right? And within this now we are going to create the node. So same data will pass to create the node. Same data we are passing. Whatever data, whenever you call the method, you pass the data. So that data will be passed here. So created a node. So we have a node, right? Now, while you create node, what will happen? This dot data is equal to data and this dot next is equal to this. You can say null. So here we are having, suppose the data is, I have called the method with data 10. So here data is 10 and here I am having null. Yes. Now, I'll create a node. I'll create a head. So I have created a head itself that would be in stack and I just do one thing. In head right now I am having nothing. So in head right now I am having null. So this is my head because this is not pointing to anything. This is reference object. So if you do not write here new and all, by default it is not referring to anything and it's null by default in Java. Objects are assigned with null value. So it's null. Here also we have null. This is my node, right? and this is node, so this node is also there, and this is referring to this. It's like a reference, you can say, variable, and we have created actual node by passing the data. Yes, I want to insert at beginning. So how to insert? Suppose at first I don't have anything in the list, right? So what you will do here? Suppose the address is 10,000. So ultimately what you want? Don't think about the logic or the code and all. Just visualize the thing. In linked list, this thing is very important. You have to draw the linked list, you have to visualize things, then only you will get the coding. Otherwise, definitely you will get confused. So always draw something like this, a linked list, take some address and all, and visualize thing how it will work. Now, if you I want to do something like this. That's it. Head should point to here if I have nothing in my list. Yes. So that's it. I want the one change. And this node would be the only one. So it would be null itself, no change. Okay. How you will do this thing? From where you will get this 1,000? From where you will get? Obviously, in node I am having 1,000. No? I have created this node. So this node is a reference variable which is in stack. This actual node is in the heap having some data, and that reference this node is having. So in node we are having 10,000. So just assign, we can say, we can assign head is equal to node. That's it. So if you assign head is equal to node, so it will be 10,000, and it will be pointing to this, pointing to this. Now we are done. I guess you are done. But the thing is, it will not work in all the cases. Let's see. And if you take tail as well, why we take tail, that also I'll show you. So at first, take node as well as head as well as tail. But somewhere, maybe in lead code question, you find out that only head is given, no tail is given. So you have to do accordingly the task. Now, suppose I'm taking tail as well, right? So if tail is also null, at first there is nothing in the list, so tail would also be null. So change the tail. If tail equal to null, then we do tail would also be whatever the node is. So tail is also pointing to this. Sorry, tail, right? But now let's see. If I have this, I have called this method once. Suppose I have called this thing something like this from the main insert at beginning. Now see this thing is still we have to modify it a little bit. It will not work for every case. And I have passed 10. Now again I'm calling insert at beginning, and I just want to insert now 11. Insert at beginning. So before here, before 10. Here I want 11. So again, if you call, again that one node would be created. So now my node, or you can say new node, you can name it new node as well, new node, because we are creating new node, node or new node. This is node. It will have some address, suppose 2000. This node is having 2000 right now, right? Let's delete it. So we'll be having these things. Okay, we will be having these things somewhere in that, not in this method, outside. I'll show you practically, don't worry. Node head, and we are having node tail as well. And suppose let's create one more thing, node temp, or let's see, whenever we require temp, then only we'll create. Let's do it as it is. Now we have a new node. Now the next line is this only, head equal to node. That's it. So now my node is, right now my new node is this one, this one. Now head becomes, it's 2000, so head becomes now 2000. Now head is pointing to this, means this reference is lost. Now we lost the connection to this. Yes, now what to do? We are having 11 null, 10 null, head is pointing to this, and we lost this. So it's not a linked list. I want 10, sorry, first 11, then 10. Now again for third time if you call, then what will happen? That new node, this will, according to this coding, this will point to this, and we will lost connection to this. So ultimately we'll be having only one node itself, right? You call it 5 times, you will get ultimately only one node at the last whenever you call. For which data you call, that only. So this is not working. You have to change it a little bit. What to change in this? Because once I now again, if I want to insert this new node, second time I'm calling, so I want head will point to this and this will point to this. This will point to this. Yes, I want this 1000 would be here and this head will point to this. So from where you will get this 1000? At in 1000 we were having first, in head we were having 1000. This is my new node, and right now this head is pointing to this, right? Now head is having in my head I am having 1000. So first do one thing, this node of next should be, or the new node of next should be equal to head. Then only here you will get 1000 and then it will point here. And after that change the head. Now head is equal to node. So that's it. Now you can afford to lose this connection because we have already established this connection. So first establish this connection rather than modifying your head. So before head is equal to node, we have to write down one more line here to make it work. What we do is, from here I want whatever the, you can say, whatever there in the head, I just want that should be in node dot next. That's it. So now my node dot next is this. This would be head. Head is right now 10,000, so that would be here. Fine, rather than null. And head is equal to node, so in head I'm having now 2000. So it is pointing to this. It's okay. Now I'm having first 11, then 10. Yes, I hope you got this. And this will work. These two line will work if there is nothing in the list. So if there is nothing in the list, head is null, right? So node of next is equal to head. Head is null. That's exactly we want null itself because there is only one element, right? Then head is equal to node. Head is equal to node 10,000. It's okay. It will work. So it will work for every case. If tail is null, then only just to tail is equal to node. That's it. Otherwise, nothing. So this is how we can insert at the beginning. I hope you got this thing. The logic behind this. It's very simple. If you visualize this thing, something like this, it's very simple. Let's try to run this for adding. I'm adding a new node. Let's see what happens. Now this is my list. Tail is pointing to this only. First we have 11. First we have 11 and next we have 10. Now I'm calling third time insert at beginning with 17. So I'll go here and data is equal to 17. So a new node would be created. A new node would be created. Here we have data 17. Here we have null and the name is node. Suppose address is 3000. So in the node I'm having 3000. So this node is now pointing to this. This is how we have created a new node. Fine. Now check. Okay, don't check. Node dot next is equal to head. Node dot next is null is equal to head. In head I'm having 2000. Change it to 2000. So now this is also pointing to this. Now change the head. Head is equal to node. In node we have 3000. So change it to 3000. So we are going to remove this link and now this head is pointing to now this new node, and that's exactly I want. Insert at the beginning. That's exactly I want. First 17, then 11, then 10. This is how we insert. So this is how we can insert at the beginning. Now tell me, what would be the time complexity for this? Are you running any loop and something like this? No. Some constant operation we are doing. Creating the node, just you can say updating the links, and also these line will take order of n itself. That's it. Sorry, order of 1, not order of n, order of 1. Constant time. So we can simply write here the time complexity is order of n. Sorry, order of 1 to insert at beginning. Order of 1, not order of n. Insert at beginning. Right? Now, let me show you. If I want to insert at the end, then what will happen? Now, suppose this is my list. This is my list. Let me change it a little bit. So this is my list. Like I have this list, I have inserted this thing at the beginning. Now I want to insert at the end. So I want to insert at end. Insert at end 20. Suppose this thing. Insert at end. Here. Here I want to insert. Here. So first, same, we will be, you can say, defining a new method. And it will not return anything. So void. Now we are having, suppose I have created my this node. So let's create it node and let's name it node itself and a new node. I'm creating a new node with passing the data. Yes, so I have created a new node passing the data that is 20 and here I am having null, right? We are having this node. So we are having this node reference variable. This is pointing to this. Suppose this is at 5000. Suppose address is 5000. So here we have 5000. This is how we have created a node. This is how we can visualize basically. Now I want to insert here. What you do? If now two cases are there. If you have tail, and that's why in the previous thing, in the previous insert at beginning, we have my own tail. Reference or a pointer is also there that is pointing to the tail. So in this case, I am having my tail. Tail is 10,000. In tail, in this, I am having 10,000. So I can directly access. I can directly go to this tail. After this tail, obviously, a tail is the last node. So after this, I want to insert. How you visualize? How to do this thing? Let's visualize. You have to change this null. That's it. I want here 5000. Yes. Then only it will point to this. It will refer to this. This 5000 is in this node. So simply tail dot next is equal to node. That's it. What do you do? And tail dot next equal to node. One thing is this. Now you have to change this tail as well. Now this becomes tail. One more thing. Now in tail, I want this address 5000. So you can do one thing. Now tail is equal to node. Because right now new node is this 5000. So now in tail, I am having 5000. And tail is this now. My new tail is this. That's it. In this case, time complexity is simple order of 1. Because is there any loop or something like this? No, we haven't traversed anything. We know tail, we go there, we simply change the links and all, and this will take a constant time order of 1. That's it. But now the second case is I don't have tail. Suppose I have only head in my list. I haven't taken any tail pointer. I haven't updated this at all. I don't have tail. I have only head. Now how to insert this here? So for first, you have to reach till tail. Then only you can insert, right? Then only you can access the next part of this last node, and then only you can, after accessing, you can change it. How to access? We don't have any pointer here. I have only head, which is pointing the first thing, first node. What will do? Let's just delete it. Now, first you have to traverse the list till the end. Yes. Once you reach here, then update. Have to traverse. One thing for sure, we cannot move head. So you have to take temp. So we have already taken a, suppose temp, I'm having a node temp. At first, same temp is equal to, we know, is equal to head. So right now we are having one more variable temp, reference variable, and here also 3000. So it is also pointing to this. Now you have to reach till here. How to traverse? We know simply. Have to do this thing. While this temp is not equal to null, not equal to null, till then we traverse. We'll not print here. Not print, we simply traverse. So we'll just simply update the pointer. So temp is equal to temp next. Temp dot next. No system dot out println because I don't want to print. I just want to reach there. Right? Till then, this thing will happen. Right? Now see. Now see, let's see if it will work or not. So temp is equal to head. Like, okay, this temp not equal to null. Yes, it's not null. So temp is equal to temp next. Now temp is equal to temp next means 2000 would be assigned here. Now temp is pointing to this. Again, while loop. Not null. Yes. Temp is equal to temp next. Now we have 1000. Now temp is pointing to this. Yes. Temp not equal to null. Yes, not null. Temp is equal to temp next. Now see the problem here. Temp is equal to temp next. In temp next we are having null. So here I am having null. Now after this loop in temp I am having null. I am having null. Not null. No, it's not true. So it will be out. So if temp is null, is it making any sense? We can we access the this next part of this node? No, because temp is null. And null dot anything, you will get null pointer exception. So how to change it? Where we have done something wrong? Just pause the video and think about this. I don't want that the temp should be null. What to do? So rather than temp not equal to null, you have to check temp dot next not equal to null. Till then we will move. So temp dot next. These things will really help you. Temp dot next not equal to null. To understand the concept of linked list. You make mistake and learn from these mistakes. Dry run the code, that's very important. And visualize the code rather than directly jumping and start writing the code on your editor and all. This will not help you. This thing will help you. Dry run and mistakes and all. Now see if it work or not. At first we are having temp. Now just remove this. Temp is pointing to this at first. Now check. While temp dot next not equal to null, temp dot next is 2000. Is it null? No. 2000 means address of the next element. It's not null. Enter here. Temp is equal to temp next. Now change. If it's not null, then only we'll change. Once you get this temp dot next null, will not change. We will not do this thing. Otherwise, temp becomes null. So then change. Now it becomes 2000. So it will be like pointing to this. Again, while temp dot next not null, temp dot next is this. Is it null? No. Change it. Condition true, change it. Now 10,000. We'll change it to 10,000 and it will now point to this. Now in temp, I am having still 10,000. Address of the last node. Means I don't know last node in programming. But yeah, on the board, I can just clearly say that by watching in by like looking at this diagram that it is last node. But now temp is equal to temp next we have seen it's 1000. Now check. While temp dot next not equal to null, temp dot next is it's null. This condition is not true. So we will not change it. So now we got it. Yeah, this is my last node because temp dot next is null. And the last node is having next null. Fine, we got it. Now we are at this node. Now we can easily change. After this while loop, what we will do is we'll just change it. What? This temp dot next is equal to whatever the node. Node is 5000. So now here, sorry, not temp. We are having temp dot next. So temp is pointing to this temp dot next is here it will be updated to 5000 and now it will point to this. Simple. That's it. It's not tail or something like this. So you don't have to change the temp and all because it's not tail, it's temporary reference variable we are taking. So I guess we are done. That's it. And if it's better to, you can say trace or you can have the size of the list as well. So just take a variable size also. Whenever you add any insert any node, just do size plus plus. So that at last you have the idea how many nodes are there in the list. Now let's code it first. Then we will see how to insert at a specific position in the linked list. Let's see. So I'm just creating in my data structure and algorithm project a new package. There we'll be discussing only linked list. So linked list. It's a new package and in this I'm going to create a new Java class. Let's take first node a separate class. Because this node we will take from the separate class we can use so that in any other program. So just to create a node, Let's take a node class and we are having int data as well as a variable, reference variable. Next, and let's have a you can say that constructor as well to initialize the node at the time of its creation itself. Let's keep it null and that's it. This is my node class. So we'll keep it a separate class. In the same package, we are having a new class and there will be having, we are discussing what singly linked list. So let's make it, because linked list we cannot name it because in Java we are having already a linked list inbuilt class in Java collection framework. So if you use that thing, you don't have to do anything. Simply you can create, I'll show you. Or rather than writing this singly LL, that's it. Let's make it singly LL, right? If you're using that collection framework, so here there we are having in Java this linked list, this thing, and here you can give integer, the list name is equal to list, and a new linked list. This is how we can create. And if you want to add, then simply list dot add, we are having just add the value, that's it. Just add and all. So you will not get how actually linked list is working and how actually this add is working and all. That's why we are not taking this inbuilt kind of thing, right? We know we have to, we have to know that how actually linked list is working in data structure, because we are discussing this. We will not use this collection framework. Once you are familiar with linked list, the basic detail, internal detail, basically, without using this inbuilt thing, how to create a linked list, how to work with linked list, then we can use this also, right? So for now, we'll not use this, right? Now, in this class, let's first take, obviously, we will require head. We will be needing, suppose, let's take tail as well, and nothing else. That's head and tail. That's it, right? If I make it private, let's see, private head and tail. So first we'll create the list, insert at beginning, and we pass 10. This is my method. So let's in this class, we'll just define this method. If you'll not take it static, so we can do one thing. We can just create object of my this singly linked list class, one object. That's it. And with the help of object, we can call. If you don't want to make the methods as static. Okay, let's now define the method insert at beginning, and let's take a variable data. Fine. Now first, obviously we create a node. So we name it new node. New node is equal to new node, and whatever data will pass with that, I want to create a new node. So a new node has been created. I want to insert at the beginning. So simply two lines you need. First we do whatever this new node dot next is equal to whatever we are having in head. We know at first if there is nothing, so we are having null. That's exactly I want new node dot next is equal to null, because if there is only one element in the list, then we update the head is equal to whatever the new node we are having. Simple. That's it. And if you want to have the tail as well, so if tail is equal to at first null, just update the tail becomes also the node. Simple. Sorry, it's not node, it's new node. And yes, one more thing, better to have always a size of the linked list. Whenever you add something, just to size plus plus, so that you have the idea how much node you are having in this list. So you don't have to count, right? But if there is some method that if there is someone asks you that how to count the number of element in the list, you can just traverse and one by one traverse and just to count plus 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 at the last return count. That's it. We are keeping the size as well, right? So insert at beginning. I guess we are done with this. Let's just call this insert at beginning. I'm just calling it, suppose, sorry, 3 times. That's it, right? And at last, now you will not see any output if you run this. Okay, you will not get any exception or error kind of thing as well, but no output is there. See, no output is there because you have inserted only, but you are not printing the list. You are not traversing the list. You are not printing. Now, let's print. So for print, we will traverse the list. So let's just, so traverse linked list, and here same, I'm just what say defining this method traverse linked list, right? Have to traverse. We know now. First check if there is nothing in the list. So we know that in that case head would be null, because at the very first, like, we have created this head and tail, so it's starting by default these are null and null. Yeah. So if you haven't inserted anything, so these are still null. So if it's null, simply you can print list is empty. Simple. Else, or if you don't want to write this else and kind of thing, so simply from here you can say return. Return means return from this method. Method means return from main, right? Suppose let's not write this else, just return. Okay. Now, if this is not the case, in that case we do something. So in that case you can directly write, no need to write down else part here. Now head is, list is not empty, there is something in the list. Now I want to traverse. So I cannot move head. So for that I'll take temp, and I'll have temp is equal to head. Maybe this will not work, but let's see it will work or not. Because for now, whatever you are understanding, whatever I'm understanding, whatever I'm explaining, for that kind of thing, for that thing we will take temp. Temp is equal to head. Okay, fine. Temp is equal to head. Now we go for while loop. While this temp not equal to null, till then we traverse. So till then we will print here whatever temp dot data, and if you want the symbol, you can print this symbol as well. And there will we will move this temp. Temp is equal to temp dot next, right? And after this loop, to you can say if I don't write anything, end or any line here, if I don't write, and if I run this right now, let's see what happens. See, 70, 20, and 10, but in a separate line. So change it. How to change? Remove this ln. So no new line, new line would be there. Now we'll have in one line 70, 20, and 10. But okay, it's not looking very that attractive or good. So just to indicate the last, here we simply write null or end or something like this. If there is a string in the list, then you can write here null. If you have simply integer, then you can take here end. So, or null you want to take, you can take null as well. So end, that's it. Simple, right? So now this thing is actually working. Yes, so traversing is done. Insert at beginning is also done. If again you want to call again one time this, and I want to insert now at the beginning, suppose 1. So what would be the list? 170, 20, 10. So let's see it, because at the beginning we are inserting. So it's 170, 20, 10, 10. I guess this is clear to you. Now let's go for, and if you don't want any tail kind of thing, you can remove this. It's not like that you will get any error or kind of thing. It will work. Only the thing is, the difference is we don't have now tail. So if you run this here, so head is, we have head is pointing to this one, but there is no tail. But if you take tail, then tail would be pointing to this 10. That is the only thing. That's why we usually take tail, just to keep our life easy. See, it will be very helpful. Huh? Now I want to insert at end. Let's do it. One more method we are having. And at the end, I want to insert 100. So insert at end. Let's define this, and same we are going to create a new node for this. So new node is equal to this data. At the end, I want to insert. So you can check for the conditions also. If head is equal to null, means there is nothing. In that case, you can simply write down these two lines. Or within the same program, if we are right now doing this thing, so we can simply call insert at the beginning. That's it. So it will insert this because only we are having one node because list is empty. So if you want to check this, you can do something like this. If head equal to null, means there is nothing. So here I'll simply call insert at the beginning, and whatever data is there, just pass that. That's it. Or suppose if you're not having this insert at beginning, you are just only coding for insert at the end. So what you will do here, you simply write down these two lines. And if you want to have tail as well, simply write down all these lines. That's it. But I'm not writing because this would be repetition of the code because I have this insert at the beginning. So I'm calling the method. In this case, head is null. Just do it and return. That's it. Now, if my list is not empty, we are having some data and I want to insert at the end. Case 1, I'm having tail with me. I'm having tail. See, I'm having tail with me. Right? Fine. In that case, what we will do? If you're having tail with you, so you can directly go to the last node. Yes. So I can simply do tail dot next is equal to whatever new node you have created. And now change the tail. Tail is equal to new node. Simple and size plus plus. That's it. I hope it works. Let's see. Now I'm just commenting out these two things. I'm having insert at beginning two times and insert at end 100 and I'm just printing the list. Means traversing the list. So that would be as it is, no change. Now at first we have inserted 10, then insert at beginning 20. So 20, 10, 20, 10. Insert at end 100. So we are having 100 here and that's it. Yeah, it's working. If I again call it, and now I want to insert here 101. So it should be 20, 10, 100, 101. Yes. So it's working. Now, if you don't call anything, I don't have anything in the list and I'm just calling insert at the end 100. But list is empty. So there is only one node. That's it, 100. Because whenever you call insert at the end, control will go here, insert at the end. It will check, create a new node and check if head is null. While creating the node, see, we have this node class, new node is equal to this. So see, data next and this and this. So next would be 0 and something like this. Now we are having head also. So it is by default null. So if it's null, insert at beginning would be called and we'll call this method, right? And these thing will happen. So if I just add some breakpoint here, you just do some, you can say dry run of this code. You will get it. If I debug this, I just added a breakpoint at insert at end. So you got it at first insert at end in this method. New node has been created. Data is equal to 100. Head is null. Tail is null. Tail dot next is something. Java.lang dot null point exception. So don't go for this. Just run this. Head equal to null. Yes, true. Call this. Now see. This would be called data is 100. So you haven't you are not able to see because you haven't added any breakpoint at insert at the beginning. So just add some breakpoint, then you will get it now. Now at first we are here, head is equal to null, yes true, just run insert at the beginning. So now control will go to see insert at the beginning within this method. Okay. Now new node would be created. It's head is equal to new node, tail equal to null, yes true, tail is equal to new node at the rate 797, some it's some internal thing. And size plus plus, so size becomes 1. See, size becomes 1. And return. So we'll go to our main, to traversing, and it will print 10 and end. That's it. So it will work, right? So we're done with. Now, we don't have tail. Suppose we don't have tail. Have to insert now. Suppose I don't have tail. So you have to traverse now till end of the that list. Once you get the end at the end node, then you can insert. So I don't have any tail. Let's just comment out this thing. I don't have any tail pointer. Now what to do? Let's see. Now to traverse the thing, obviously we should have a temp node, temp variable, and we will assign temp is equal to head. So this is pointing to the starting node. Okay, fine. Now we go. While this temp dot next not equal to null, not equal to null. Okay, we are traversing here itself. We are traversing. This is also traversing, but here we are taking temp not equal to null and we are printing. But here we are traversing. We are not printing. I don't want to go exactly at the this last. I don't want to print. I just want to check temp dot next. If it's null, then I don't want to change my temp. Otherwise, if you change it, it's null point exception. So first check temp dot next not null, then only change my temp. Then only change my temp to temp dot next. Yes, we are done with this. So after this, we'll be at the last. Temp is pointing to the last node. And now we can simply change temp dot next is equal to whatever the new node and size plus plus. I guess it should work. So this is insert at the end. We don't have any temp in that case. We don't have any tail in that case. Right? Let's see. Let's just first insert at beginning 10 and insert at end 100. That's it. These two methods I'm just calling. So 10, 100. It should give that thing. Yes, we got it. Again, if I 101 also uncomment this. So 10, 100, 101. Yes. So it's working. Right? But if I change it, suppose in this insert at the end, I change it while temp not equal to null, till then change temp and then change it. In that case, you will get exception. Let's see this. If I run this, you will get null pointer exception. See, because at last temp is null. And now after temp is null, this condition is not true. So we will go into this part. So null dot next. Obviously it's null. So you cannot access null dot next kind of thing and all. So it's null pointer exception you will get. Null pointer exception. Right? Remember this thing. So in this case, temp dot next. But if in traversing, if I write temp dot next not equal to null, till then print and change. This is we are changing in traverse print list. Traverse linked list. Let's see. 10, 100, 101. It should print this, but it will print only 10, 100, not the last one. Why? Why? Not the last one. This thing is, this is for your assignment, your quiz question. You have to find out. I have changed this traverse a little bit, this method a little bit. While temp dot next not equal to null, then I'm printing the data and that is. But the correct one is this. So why you have to try in that? Why if I write this thing, it's not working? It's not printing the last element. If I go for this again and I change insert at end, I just want to insert here 134. Now it will print 10, 100, 101, not 134. Try run this and find out this. But for now, let's just change it to temp.next not null. So we're done with insert at end as well. Now insert at specific position. Let's discuss that thing. So suppose this is my list and I want to insert at a position. Suppose position is something I don't have any index kind of thing in linked list, we know. So we assume that position 1, then 2, then 3, and this 1, 2, 3, 4, something like this. Size of the list is also 4 in this case. Yes. So we can give position 1. Yes. In that case, want to insert here. If position 2, I want to insert here. If position 3, I want to insert here. If position 4, I want to insert here. If I give position 5, that is also valid. Position 5 means here I can insert. But if you give position 6, that is not valid position. If you give position 0, that is also, we consider that it's not valid. I assume that I start position from 1. Maybe somewhere it is considered that it's a 0, 1, 2, 3, something like this. So you have to check that thing also. If position is less than equal to 0 or position is greater than size plus 1. Size plus 1 is valid. If you give 5, I can insert here. If you give 6, I cannot insert. Then it's invalid. Otherwise, we can insert. How you can insert? See, if suppose I have something like this, this is my list, and I have created a new node, and I want to insert my position is suppose 3. I want to insert at 3, and in my node I am having suppose 15 or not 15 is there. I can add duplicate element also, duplicate node also. Don't worry. If 15 is there, 15 would be added. Don't worry. So if I take 50, that is also fine. You can take duplicate also. And if you create a new node, this would be null. And the name I'm taking new node. So this new node is having some address, suppose 2000. So here I'm having 2000 and this is pointing to this. So this is how we have created my new node. I want to insert at position 3 here. So visualize this thing. Don't write down the code. Visualize this thing. Here means basically at third position. So this would be at fourth position. So something like this I want. This would point to this and then this would point to this and break this. Now position 1, 2, 3, 4, 5. This is how we can insert at position 3. Not after the position, at this position, at third position I want to insert. So just create a new node and you have to update these two links. That's it. But for this also you have to take care. How? Maybe you think, okay, we are here at position 3. Have to, first thing is have to reach till position 3, because if you want to update the links, then I want to access this thing also 500, the address of the next node. How to access this? There is no pointer accessing to this node. So first I want to access this address, then only I can just write here 500. Yeah, the address of this node is I get from new node. So once I reach here I want this address, new node, this I'll get from here. But the address of this I want to insert here, because this node now point to this. This address you can get from here, the next pointer of this node. You have to reach till this node, then only you can insert. So you have to reach till second position, till position -1. Have to reach till here. Reverse. That is the only way to reach, because we are working in linked list. We have only head, or if we are lucky, then we have tail also. But then I want to traverse till this position. Maybe I'm having 50 node and I want to insert at 40 position. So you have to reach till 39 position and then you can update. Have to reach. Yeah, we have loops. We can traverse. So now traverse the thing. Let's see how we will traverse this thing. At first, we are having head. Head is equal to this pointing to this, and we will see the edge cases also, like when head is not there, I mean head is null or list is empty, then what will happen and all. But for now, let's have, this is the list and I want to insert at position 3. So now let's have to move till here. Obviously you have to take, we cannot move head, so we have to take temp, and at first temp is equal to head. Fine. Now we are having one more temp is pointing to this, having this address, same address 1050. Hypothetical addresses, they're not actual. Now let's see. I'm having, where is my current position? That also you have to track. Na? My current position right now is 1. If I move here, then my position will become 2. If I move here, then my position will become 3. And you have till the current position less than position -1, till then you have to move. So for that you have to take one more variable int your current position. Right now, my current position is 1. Yes, I'm here. Current position is a variable. Let's say current CP, current position is 1 right now. I'm here. Temp is here, head is pointing to this. Now, we say while my current position. Because, see, I'll not say while like temp dot next or temp or data or something like this. I cannot write down this thing in while loop because the condition is I want to insert at this position. So you have to reach till this position. Now you will move until you reach to that position. So obviously you have to track. So while my current position is less than whatever position I'll give. Let's take a variable POS. POS is 3. Whenever you call the method, then we pass POS 3 and data as well. POS minus 1. Not till POS. POS minus 1 till here. Till then, we keep changing this temp. So temp is equal to temp next. And as well as current position plus plus. Because obviously, now current position is 1. It's less than position minus 1. 3 minus 1, 2. Yes. Temp is equal to temp next. Now temp would be pointing to this. Temp next is 10,000. So in temp we are having, 1,000. So now it will point to this. And current position now plus plus. Current position becomes 2. Yes. Now we are at 2. Yes. So current position is 2 less than position minus 1, 3 minus 2, 2. Is it true? No. Now we will not move. Now temp would not be temp dot next. We are here. Temp is here. And that's exactly I want. I want to access this node which is previous to my position. Previous node to my position whenever I want to insert third here. Right? So I got it. Suppose position is 4. Suppose position is 4. Here I want to insert. Then I have to insert this here. So this will point to this and this will point to this. Between these two I want to insert at position 4. Right? So then you have to reach till 3 because I want to access this 100. I want to access this 100. This you can say address of then this node which is at position 4 because I want to change it to this and then this. So this 100 should be here. To access this 100, we need to reach till here. That's why position minus 1. Let's change it to, we keep position 3 itself. That's it. Now we reach till here. Now change. Okay, for change, how to write? Update the link. Now you have to do this thing, this and this. So this 500 should be here. Then only it will point to this and the node of this new node should be here. So this we can easily get with this from this new node. So if I write something like this, my temp is now pointing to this. So I want temp dot next equal to new node. That's exactly I want. Temp dot next is 500, new node is 2000. So it will change. It will be changed to 2000. Right? So now my 2000 means now this is pointing to this. Yes. Now we have lost this connection. Now see, have to update this. Now here I want the address of the next node that is 500, hypothetically 500. From where you will get this 500? Is there any way? No, because you have lost this connection. There is no way you can get 500. So like this, when to write which line, this also you need to take care. We cannot simply write down this thing. First, otherwise you will lose this 500. First establish this connection. So before this line, what will I? First establish this connection because the 500 is only here. And the only way to get this 500 is temp dot next. If you change temp dot next first, you will lose it. Okay. So temp dot next. Here we are having temp dot next is this address that is 500 and I want to assign this here. So new node dot next. So whatever new node dot next is equal to this. So 500 is now here. Now this is pointing to this. Now you can change it. Now simply you can change it. Temp dot next is equal to whatever the new node. That would be 2000. It will point to this and we lost this, and that's exactly we want. Now we will move from here, 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 and here. As a third position we have inserted my new element. Right? I hope you got this. Now if position is suppose 1, if my position is 1, in that case will it work? Let's see. Position POS is 1. Sorry, POS is 1. So we have temp is equal to head, current position is also 1. Here we have 1, this and this. At first we are having 1. While current position less than equal to position minus 1, current position is 1, position minus 1 is 0. Is this true? No. So there is no changing kind of thing. And that's exactly we want. So directly we go here. Whatever new node dot next, suppose this is my new node, rather than inserting here, I won't add position 1 means here. Here. So you have to change it like this. Here I want this node 50. So new node dot next, new node is this, dot next is equal to temp dot next. Temp is here, temp dot next is 1000. So here we have 1000 and it will point to this 1000. And temp dot next is this is equal to new node is equal to whatever the new node, suppose it's 2000. So now here we have 2000. So this will point to this. So this would be something like this. We are having first this, then this, then this. So it would be not at first position. It would be at second position if we follow this thing. So this logic will not work if position is 1. So for that, before writing this, once we check before that if head is null, sorry, if head is null, and in that case, if position is given 1, in that case, you just call insert at the beginning and that's it. If position is not valid, then also we'll check. Third case also we'll check before actually writing this thing. If, what we say that if your position is equal to 1, if position is 1, we cannot follow this thing because this will do something else. It will add at second position, not first position. So we can't do this thing. Right? So if position is 1, I want to insert here, like this I want. So simply we can do insert at the beginning, simple. So for that, what you do is, we do what? Here, this new node, or we have here, what? New node or node, whatever you call it as. Here I am calling new node. So new node dot next is equal to whatever the head is. Head is the address of this. So 1050. So it will point to this and we'll update the head. Head is equal to whatever the new node. So this thing you need to take care. This is a special case. These things, this while loop and this thing will handle everything, every position except position 1, from 2 to any position. But if position is 1, then you have to insert at the beginning. So this thing will not work. Right? So this thing you need to take care. Every other cases will be handled by this. I hope you got this. Have to insert at a specific position, any position. If suppose position is given, let's take, if position is given 5, then how it work? Will it work or not, this code? So 5 is 1, 2, 3, 4, somewhere here. Yeah, we can insert here because it's exactly same as insert at the last, at the end. So it should work. So position is not valid, not invalid, it's valid. Okay, let's see if this is work. Position is 1, no, this will not go into this. We'll go into the else part, and else you'll write down this thing. Or if you do this thing, you can just simply here return. That's it. So that you don't have to write down else. So else, now current position is 1, we are here. While current position less than position minus 1. It's true? Yes. Enter here. Temp is equal to temp next. So at first, obviously, we are having temp here. Temp is equal to temp next. Now temp is pointing to this. Current position is also plus plus, so that is 2. So we are here. Current position Less than position minus 1? Yes. Again, temp next. So now temp is pointing to this. Current position is 3. Again check. 3 less than position minus 1. Position minus 1 is 4. Yes, true. Enter here. Again, next. Temp is equal to temp next. And position is 4. Now temp is pointing to this and we are position is 4. Current position is 4. Less than 4? No. Now it's not true. Now out of this while loop and do this. New node dot next. So we are having here, suppose this is my new node. So new node, suppose I want to insert here anything 20. New node dot next is equal to temp dot next. In temp dot next right now we are having null. So we will assign here null. It's okay. It will work. Temp dot next is equal to new node. So temp dot next is this. New node will have some address, suppose 5000. So we'll assign here 5000. Yeah, that's exactly we want. So this will work for this position as well. Only if position is 1, in that case you have to write down these two things. This logic will not work. It will be like insert at the beginning. So you have to write down this thing. So this is how we can insert at any position. Now you can write down this and you can dry run your code. Let's code this. So let's take a function insert at position. Pass the data you want to insert. Any data, suppose 25 I want to insert, then the position where you want to insert. Suppose position is 2. Suppose position is 2 and we have called insert at beginning, 10 insert at end, 100 insert at end, 101, 134. So right now my list is 10, 100, 101, 134. Yeah, right? So I want to insert at second position. So my after inserting my output should be 10, 100, 25, 101, 134. Right? Let's see. Let's Before traversing, let's just define this method insert at position. Int position and data I'm having. So let's create a new node at first, and whatever data we pass accordingly we create a new node, right? If suppose there is nothing in the list, if head is null, we have to cover all the cases now. So if head is null, there is nothing. In this case, if the position given is, again check. In this case, if position given is 1, head is null means there is nothing in the list and position is 1. So we have to insert at the beginning only. So we can simply call here insert at beginning. I am calling here insert at beginning because in the same method I am having this method, so I can call. Otherwise, whatever coding you have in this insert at the beginning, you just write down that code. This thing. New node is equal to this, head is equal to new node and all. Right? Rather than calling this, I can just write down this also. Fine? Okay. I don't want to write down the redundant code. That's why I'm just calling the same method insert at beginning and simple return from this method. So where I call that, there it will return. So one thing is done if this is the case. But if my head is not null and if position is 1, in that case you have to deal that thing differently. If head is not null but position is 1, in that case what you will do? Okay, we have done that thing. Okay, so let's name it new node rather than no. Simple, because we are creating new node. So this new node, we have new node dot next is equal to whatever the head is. And now head becomes whatever the new node is. And just do size plus plus and you can simply return. That's it. Otherwise, if position is not 1, head is also not null. So now what to do? For that, let's take a variable current position is equal to 1. Right now it's 1. And let's take a temp node, and temp is equal to head because we'll move further. So we take a temp. Now check. While my current position is less than position minus 1, because till then I want to remove. Till then, just move forward. So temp is equal to temp next. Current position will also be plus plus. Till then, just do this thing. Once you reach to correct position till position minus 1, then stop and then do something now. Now, change. Whatever my new node dot next, first you have to establish the right link. So new node dot next is equal to whatever my temp dot next. Yes. And then change temp dot next is equal to new node and size plus plus. So I guess you got it. Insert at position. One thing is also left. If position is not valid, in that case, what you will do? If position is suppose 100, there is no 100 position here. So print a message that position is invalid. So check that thing also. Suppose at first itself I'm checking if my POS is it's less than equal to 0, or my position is greater than size plus 1. Sorry, it's POS position. It's position. Then we simply print position is not valid. Some message you can print, right? And simply return from this because I don't want to move further. So simply return if this is the case. If head is null and if again position is 1, then do this thing. If position is 1, then do this thing. Otherwise, for every rest of the cases, this code will handle rest of the cases. Now, insert at position 2. Let's run this and see what happens. So it should be 10, 100, 12, sorry, 25. Sorry, it's a 10. At position 2, I want to insert. So at position 2 is 25, then 100, 101, 134. If I want to insert this at position 1, then what will happen? Let's run this. So it's see. At one position we are having this. Fine, it's working. If I want to insert at position 3, let's see what happened. So it will be 10, 100, 25 at position 3rd. 1, 2, 3. Then 101, 134. If I want to insert at position 4 or 5, let's say. 5 means at the last we have. So 25. But if I insert position is equal to not 5, it's 6. It should give me some error message. Position is not valid. And this is my list because I have only 4 elements. So I cannot insert at 6th position. So you got it? Insert at position, right? Now one more thing is there. Insert, suppose, not position. I just give you insert after 100 or insert after 101 or maybe insert before 101 or insert after 134. I give you the value, the data. After that data or after that value or before that data or before that value, you have to insert. So I'll discuss one thing. After the value have to insert, then you can just modify it before the value have to insert. So this is, we were just in this case having the position, but I don't want any position here. I want to insert after the given value. So whenever I will call that insert after value, I will pass the data I want to insert and the value, not position, the value. Suppose I am just passing the value is 7. 7. So after 7, here I want to insert. And the data I want to insert is suppose, let's change it. And this is my last. It's null. Data I want to insert is 50. So after creating a new node, I'll be having something like this. So I'll have this new node and this is pointing to this. Whatever, suppose address is 5000 or anything. So in new node, this is a reference variable having 5000 and this is my new node and I want to insert after the 7, after this value. Now, obviously, you have to search where is that value and then only after that you can insert. That is common sense. So to search for this, we have to traverse. To traverse, we take a temp. We'll start from head, take a temp and note current position. Temp is equal to head, something like this we have, and we move. So we check now while temp dot data, because we are checking the data, the value, the data. Once the data is 7, then after that you can insert. So data not equal to whatever the value I give, whatever the value I give. If the data is not equal to value, till then we will move. Till then we will move further. So temp is equal to temp next. Temp dot next. Let's see it will work or not, and we'll maybe change it. So temp is equal to temp dot next. Suppose we are writing something like this. At first, temp is here. Temp dot data is 10. Is equal to the value? No. So temp dot next. Temp would be here. Is it equal to the value? No. Move next. So now temp is pointing to this right now. Right? Temp is pointing to this. Is equal to value? Yes. Stop it. After this, I want to insert this node. So something like this I want to do. And this and break this. So I guess we can do, maybe you say that, okay, first just establish the link, right link. So do what? Whatever the new node dot next is equal to whatever the temp dot next. Temp node next is 100. So 100 would be here. 100 is the address of, suppose, hypothetical address of the next node. So it will point to this and then change it. And now I'm having my temp dot next is equal to whatever my new node. And yeah, we're done. Maybe you are thinking something like this. Then size plus plus, and that's it. Let's see it will work or not for all the cases. In this case, it will work. Now suppose the value exists in this case. Okay, fine. Now the value is 10. Suppose value is 10. So node is temp is equal to head, while temp dot data not equal to null. Temp dot data is equal to 10. Is it equal to, is it not equal to value? No, this condition not true. It is equal to value. So we'll not move further. Okay, fine. That's exactly we want. Now go to the next line. New node dot next. So whatever new node is there, suppose this dot next is equal to temp dot next is equal to 10, this 1000 would be here. So this will point to this. And temp dot next is equal to new node. So here we have 5000. So this will point to this. That's exactly what I want. After 10, I want to insert. Okay, fine. This will work for this also. Let's see. My value is not present in the list. My value is something like I'm having, suppose 500. 500. Now what will happen? See. At first, temp is here. This condition true? No. Temp dot next. Temp would be this. Is this condition true? No. Temp would be next. Temp is equal to temp next. Is temp of data equal to value? No. Temp next. Temp is here. Is this equal to value? No. Temp is equal to temp next. Now temp is equal to temp next means null. Now at last temp would be null. Right? Now check. Temp dot data. Null. Null dot data. If you try to do this, you will get null pointer exception. Now what to do? This will not work in this edge case. Think about this. I just got this thing also, but then I thought I'd write on this, and then I thought, and then I got that, okay, I can write down, I can modify loop or something like this, then it will work. So this is how things will work. This is how you are going to, you can say, build the logic. Don't see my solution. If this is the problem here, pause the video right now and think how you will solve this question, this problem. If value is not there, what to do now? If value is not there, obviously you should print such value doesn't exist, so we can't insert after this value, something like this. How to do this thing? So one thing what we can do is, I will move temp next, temp next, temp next till here. I don't want in my temp I have null, because if in temp I have null, you will get null point exception. So maybe you can say, I can just, maybe you can update like one condition is this, and my temp not equal to null. Till then we move. Till then we move. Till then we move. Let's see. Value is same 500. Temp is here. Temp dot data not equal to value. Yes. Move next. Temp is equal to temp next means we are here. In temp, we are having now 1000. Is not equal to value and temp is not null. Both conditions are true. Enter here. Temp is temp next. So now here temp. Value not equal to, here the data not equal to the value and temp is not null. Move here. Now in temp, I am having at last 100. 100. Temp, I am having 100. Now check. Temp dot data not equal to value. Yes. Condition true. And temp not equal to null. Yes, we are not having null. Again, we will enter and again we will assign and then ultimately it will become null. So this will not work. Now again, null load data will check and you will get null point exception. So this thing is not going to work. What to do now? Can I do one thing? If I change it, if I put this here and this here. So if I change it a little bit, this while loop, this is my condition. Before this, I write and temp not equal to null. Here I am writing while. Just delete it. Before first condition, I'll check this and then this. Let's see. Start from starting now. Temp is at first here. Is temp equal to null? No. And temp dot data not equal to value? Yes. Because to make this condition true, these two has to be true because this is logical and both are true. Enter here temp is equal to temp next. Now temp is pointing to this. In temp, I'm having now this address. Now check again. While temp not equal to null, true. Data not equal to value, true. Again enter. Now temp will point to this. Now in temp, I am having this address. Check the value. True. Check the condition. True. True. Because value is not 500 here. We have 7. Move next. Next. Sorry. Temp. Now in temp, I am having 100. Yes. Temp is pointing to this. 100 means address of this. Whatever the address of this last element. Temp not null? Yes. Temp dot data not equal to value? Yes. Temp is equal to temp next. Still, temp next is null. So it will having null. Yeah, it will have null. But now again check while condition. While temp not equal to null, this condition is not true because temp is null. So now we will not enter here. Temp not null we are checking. Here we were checking this condition after this. So first we were checking null dot data. Whenever you try to access on null something, it will give you null point exception. But here we are not doing anything like temp dot something. No, we are checking null temp not equal to null. That's it. But it's null. So will not enter here. Now you cannot directly write this thing. Suppose if I write, because temp is right now null. If I write new node dot next is equal to temp dot next. So temp is null, null dot next. Again, you will get null point exception. So how do you have to change it? Before this, before writing these lines, you have to put a condition. If before this, if temp not equal to null, then only we do this thing. Then only we update the thing. If temp is null means you have reached till here and this value doesn't exist in the list. So if this is the case, then this. Else, after this, if in else part, you simply write no such value exists. We cannot insert the data after this value. That's it. So you have to change a little bit the loop and that's it. You're done. So this thing you will get why I'm writing this condition here and here. Once you do yourself these things with your hand, not on the editor, on a pen and like a paper with a pen. Visualize the list, do how to change it and all, write down this thing, then try to change, think, take a break and then think. Then go to the editor and code. Now let's code this. So we have a method, suppose insert after value, and I want to insert suppose 189 after a value 10, because in the list I know I'm having 10, then 100, then 101, then 134, then 25 as well. So after 10 I want to insert. Let's define this method before traverse list. Let's define it. So first of all, we create a new node to insert the node. Obviously, we have to create whatever the data you have passed with that data. Okay, we are done. Now we have to traverse. After value, we need to insert, right? First thing we have to take, obviously, we know node. We'll take a node temp, and at first we call temp is equal to head this thing, right? So let's code it now here. Fine. Now we move. While at first we'll check. I'm not saying that it is the only way to write this while loop and to check this thing. You may write this some other way also. So you have to now think how you can write down this looping condition maybe in some other way, right? But the task should be after value it should insert, and if value is not there it should give you some that valid error message. So temp not equal to null, end temp dot data not equal to the whatever the value we give. So for better understanding we just keep these are two conditions in brackets, something like this in round brackets, right? Till then, if this is the case, till then we will move the temp. Temp is equal to temp dot next. Yes. Okay. Now once you reach to the that value, so you have to check first. If my temp is not equal to null, then only obviously I found the value and I'll insert. So now what you will write your new node. Sorry, I have named this node. Let's name it new node for better understanding because we are creating new node now. So my new node dot next is equal to whatever my temp dot next, and then I'll change my temp dot next is equal to my new node, and I'll do just simply size plus plus. Else if temp is null you can simply print a message no such value exists. No such value exists in the list, so cannot insert the data, something like this, right? So I guess that's it. Now we are going to, so if I call it insert at the beginning, then end, something like this at position 6, not position 6, let's change it to position 2, suppose, and then insert after value 10. After value 10, what do you think? What output we should get after calling all these things? So I'm getting 10. Okay, insert at beginning. At first, we are having, if after inserting at position till here, if I again print, suppose let's print this obj dot traverse linked list before inserting after value, and then we print after inserting the value. So before inserting the data after the given value, the list is 10, 25. Then we have 100, 101, 134 because we have inserted at position 2, 25. So it's at 2. Now after value 10, I want to insert 189. So after 10, I'm having 189. Yeah, we got it. Let's see. After value 101, I want to insert 189. So I hope it works. Let's see. Yes, after 101, I'm having 189. It is working. Suppose I want to insert after value 1, but there is no 1 here. So it should give me no such value exists. See, no such value exists in the list, so cannot insert the data. So list is my as it is. My list is as it is. After 134, I want to insert, means at the last. So see it will work or not. Yeah, it's working. After 134, it's 189 we got. This is my value, this is my data. I hope you got this. Right? If I ask now what is the time complexity? At the beginning, it's order of 1. It's very simple. At the end, if you have tail, it's order of 1. If you don't have tail, it's order of n because you have to traverse till the end. At particular position, now position may be after obviously n element I want to insert. Position may be my data is in my list, I have 50 elements and I want to insert after 49 or at 49. So you have to traverse till at the end. So in the worst case, it's order of n. N element you have to insert, traverse. to get till that position. After value, if you want to insert same order of one, order of n, maybe the value is at the last, present in the list at the last. So in the worst case, you have to uh, traverse till the last. So in the worst case, it's order of n maximum. Minimum is maybe value is at the first position only, so it's order of one itself, right? So now I hope you got this. Now maybe we can ask like you are given a value and before this value you have to insert. I mean the given value is suppose 7, not after 7, before 7. So 7 is this, before 7 I want to insert here. You have to update this. So I think you can easily update this. You have to traverse till here, where the value here to the previous node till here, and then you can insert update the link. Before position, after position, at position if you want to insert that exactly like before position itself, right? So if 3 is given, so before this 3, after 3, after position, if 3 position is given, but I want to insert after this 3 position, have to insert. So these are not that much tough. You have to change a little bit in the while loop and all. So I guess you can easily do this if you go to whatever we have done till now. If this thing is in your mind, then you can easily update those things. So this is your exercise. Insert before the value, insert after a given position. This method, these methods you have to implement yourself. So this is how we can insert in a linked list. Now in the next lecture, we'll see how to delete from a linked list. Delete from the beginning, delete from the end, delete from any specific position, and delete a specific value. How to delete that thing we'll see in the next lecture. So now it's in the next lecture. Till then, bye bye. Take care.